So let's work on problem number 14. What is the distance between points A and B, where point A is -2, 1, and point B is 1, 5? Now, I happen to have some graph paper this time around, so we're going to do this problem. Rather than using a sketch, we'll actually use graph paper. So A is -2, 1, so that would be -2 on the x-axis and +1 on the y-axis. So this would be point A, and I'm just going to make a note here, it's -2, 1. And then point B is 1, 5, so that would be 1 on the axis and then 1 x-axis and then 1, 2, 3, 4, 5 on the y-axis, 1, 5, point B. Okay, so we need to find the distance between these 2 points. So let me go ahead and join the 2 points with a line. And okay, so I'm not told exactly what method I need to use, so I'm going to go ahead and I'm going to use the Pythagorean theorem only because for this particular problem it looks a little bit easier. And that's because I can already see what the right triangle would be. Okay, it's pretty easy to see it, but if for some reason you have trouble in figuring out what that coordinate should be of the third point of a right triangle, you might want to follow this following suggestion. Look at the point that's higher up, which is B, and circle its x-coordinate. Then look at the point that's lower down here and circle its y-coordinate. Okay, so we circled the x-coordinate one, and we circled the y-coordinate one. Now go ahead and find point 1, 1. Okay, the point with the x-coordinate 1 and the y-coordinate 1. 1, 1. Guess what? That's the third point. Okay, that will always work. So if you're having trouble figuring out how to find that extra point, the third point of the right triangle, that little technique can always work for you. So now let's connect points B. We'll call that third point C. Let's connect point B to point C. Okay, now let's connect point C to point A. Okay, and there we've got it. We've got our right triangle. Zoom in maybe a bit more and actually draw in the right angle over here. Okay, so that's the little right angle symbol. And now let's count. Let's count the sides that are at right angles to each other. And we'll call this side little a, we'll call this side little b, and we'll call the hypotenuse C. And remember, it's C that we're looking for, because we're trying to find this side. The distance between points A and point B, which is the measure of AB, which we're calling little c. Okay, so we've got our Pythagorean theorem, which is a squared plus b squared equals c squared. And now let's plug in A and B. So this is A. Let's count. How large is A? 1, 2, 3, and 4. Okay, so A is 4 units long, so that would be 4 squared. Plus, what is B? Well, let's count it. 1, 2, and 3. Okay, so B is 3. So that would be plus 3 squared equals c squared. Now let's just solve this equation. 4 squared is 16. 3 squared is 9. And 9 plus 16 is 25. So 25 is equal to c squared. Now we can take the square root of both sides. And remember, the square root cancels out the square. That gives us c equals, and the square root of 25 is plus or minus 5, but a distance can only be positive. So it's only the 5 that we're interested in. So that is the answer to this problem. The distance is 5. So let's go back to our multiple choice questions here, and let's see what are the choices. And we see A is 5. So the answer to this question, 14, the answer to 14 is A. Okay, so the answer to 14 is A.